At this point, we have completed the initial dashboard setup and can now move on to build the Smart Breakdown section. For the budget breakdown section, we're going to start by unhiding those hidden columns, as we need to apply some powerful pre-calculations. Those pre-calculations have the goal to first retrieve all relevant data, which are the relevant items with their respective budgeted and tracked amounts for the selected period, and then to automatically sort the category items within each individual type section, first by tracked amount and second by budgeted amount. As the first step, let's format this gray subheader row where we're going to put in the column names for these pre-calculations. And for these column names, we want to have a font size of 8 and a text alignment to the center and middle. Those first 10 columns from column C to L will cover the dynamic retrieval of only the relevant header, category and total items from the income, expenses and savings type of the budget planning sheet, while ignoring the unused placeholder category rows in between, and then also the dynamic calculation of the budgeted and tracked amounts for each item based on the selected year and period. While the remaining columns M to X are then required to build up an automatic sorting mechanism that sorts the category items within their individual type section, first by tracked amount and second by budgeted amount. For a better focus on these first 10 pre-calculation columns, let's temporarily hide those remaining calculation columns as well as the visible breakdown section. And also adjust the size of the separator column between the sections. That way we can now build up those 10 pre-calculation columns while having an easy access to the 2 drop-down selections for year and period. Before we start, let's enter the column names and also visually structure those 10 columns. The first column will be called Row ID, and this is where we're going to bring in the row number of each relevant item from the budget planning sheet. Then, to always know where the relevant type section starts in the budget planning sheet, the second column will make the relevant type header row ID available in each row in here. The next 4 columns will then be binary classification columns to figure out if the respective row from the budget planning sheet is either a header row, a category row, a total row, or an empty row. And based on this information, we can then dynamically retrieve the type, so either income, expenses, or savings for each item, and of course the item name itself. For each category and total item, we then gonna calculate the tracked and budgeted amounts based on the selected year and period. Let's add some borders to visually separate those ID, binary classification, and actual content columns from each other. We will add all column calculations up to row 50 on this sheet. However, if you need more room as you plan to define a significantly larger number of custom categories, you can either cover more rows now or later expand the calculation range using the autofill functionality. To add those borders, let's open the advanced border options, select this midlight gray as the border color, and add a left and right border to each individually selected range. As the final preparation step, let's define dynamic name references for each column so that all the column formulas can reference the same row value from another column simply by its column name. Let's select the first cell in the row ID column, go to the Formulas tab, and click on Define Name. The name for that reference is already proposed as row_ID, just like in the column header. Then we want to limit the scope to this budget dashboard worksheet only. And for the reference, we're gonna leave the $ in front of the column character to have it fixed to this column, but make the row relative by removing the $ so that the row always adjusts to the row from which that name is referenced. So when we now reference row ID from another column in this first row, the row ID value in the same row is referenced, just like when we call it from another row or column. As you can imagine, using this technique of dynamic name references will make all our formulas that somehow rely on other column values way easier to build and understand. So let's take the time to set up equivalent dynamic name references for the other 9 columns here as well. For the header row ID, let's again select the first cell in that column, click on Define Name. The name is already proposed correctly. The scope is the budget dashboard worksheet again. And then in the reference field, we remove the $ in front of the row number. Then the same for the is header column. The is cat column. The is total column. And the is empty column. Just as a quick side note, if the name is not proposed correctly by Excel, which happens from time to time, just enter it manually by yourself. Eventually, we also cover the type column, the item column, the track column, and the budget column. After taking this effort, each of these column values is easily accessible from any other column. And with this, we have done the best possible preparation to now quickly build our column calculations. We're gonna start with the row ID column. And in this column, we want to dynamically bring in all the relevant row numbers from the items in the budget planning sheet, starting with the row number of the income header, which is 9, then all the defined income categories, which currently are 10 to 12, then skip all the row numbers of those unused placeholder rows and jump straight to the row number of the income total row, which at the moment is 20. Then with one empty row in between, we want to have the row number of the expenses header as the next row ID, then all the row numbers of the expense category items, then again skip all the unused placeholder rows and jump straight to the row number of the expense total row. And then of course the relevant row numbers for the savings section using the same approach. For a better understanding of the formula that we are about to build up in the row ID column, let's start by demonstrating how the item column would look like if we brought in all the items using a direct reference to the items in the budget planning sheet. In this simple scenario, we would directly reference the income header cell and then just use the autofill handle to bring in all the subsequent items from that column. As you see, that would bring in all the category placeholders as well, which we actually don't want to have in here. And for that reason, we want to find a good way of dynamically cutting them out. As a first step, let me show you how we can bring in those exact same item values using a row ID as an intermediary, because we can easily bring in the corresponding row numbers from the item values into the row ID column by referencing the income header row as a starting point, and then for all subsequent values, simply take the previous value plus 1. That produces this incremental series of row numbers in the row ID column and allows us to return the exact same item values in the item column using the index function, for which we only have to provide this column C from the budget planning sheet as a return array, and then simply enter the row ID as row number from which the value in this column shall be returned. Simple as that. To catch any potential error, let's wrap this into an if-error function that returns an empty string if any error occurs. And when we hit enter and update all the cells in this column by double-clicking the autofill handle, you see that this short formula now produces the exact same result, but is now fully based and dependent on the values in the row ID column. And that means if we now find a robust way of not printing all the row numbers, but only the relevant ones in a consecutive way into this row ID column, then suddenly only the relevant items will be visible in the item column. So let's do this. The first row ID will always be the income header row, as this defines the anchor point for our row ID calculation. What we're gonna change though is the formula for all the subsequent cells, because obviously we will have to make this a bit more sophisticated than this formula in here. However, what we're gonna do in a similar way is that for every cell in here, we're gonna take a look at the previous row ID in the cell above. And based on what that previous row ID in the cell above is, we then gonna decide what is the next relevant row ID to be displayed in this cell. As this formula will be a bit larger, let's increase the size of the formula bar, and then we start the formula with a first if statement that checks if the previous row ID equals -1, as -1 is the row ID that we're gonna print if there's no more relevant row number to show. And thus, if the previous one is -1, the next one will automatically be -1 as well. Okay, if the previous row ID is not -1, then we're gonna go from top to bottom through all the relevant item row numbers in the budget planning sheet that we know. As we go from top to bottom, the first relevant items after this initial cell with income header row are the first to the last income category item, with the first item's row number being equal to the income header row +1. And now to make sure that we always gonna print out the row numbers of all the defined income categories, no matter how many there are, we can say that as long as the previous row ID is smaller than the income max row, which we have dynamically defined as the row number of the last element in the income category table, the row ID of this cell equals the previous row ID +1. And as soon as the previous row ID equals the income max row, we know, okay, so we have printed all the row numbers for the income category items in the cells above, so as we want to skip the row numbers of the placeholder rows, now in this cell we obviously have to return the income total row. Let's take a quick break here by saying for all the other cases we're simply gonna return a -1, and update all the subsequent cells with this new formula. The magic you can see now is that by dynamically printing only the relevant header, category, and total row IDs for the income type, using those predefined positional row information, we have produced a condensed output in the item column that only shows the corresponding relevant items and skips all those empty placeholder rows in between. Let's continue with this formula and start covering the expenses section as well. To separate the income and expenses section from each other, we want to make sure that there is always exactly one separator row. So when the previous row ID equals the income total row, we know that as this row ID, we want to have a row ID that represents a separator. Now intuitively, we could just return a -1, but the biggest problem here is that in the next cell below, we would not be able to figure out what the next logical row ID is based on the previous value. So we need something unique that tells us that this is the separator row between the income and expenses section. So let's make that a text string like /1, and then in the next if statement we can refer to that and check if the previous row ID is that /1 separator row. Because then the next logical row ID is obviously the expenses header row. As we know that the expenses category items are coming right after, we know that as long as the previous row ID is smaller than the expenses max row, we have to simply return the previous row ID +1, just like we did for the income category items. And as soon as the previous row ID is no longer smaller, but equals the expenses max row, we want to skip all the placeholder row numbers and directly return the expenses total row. Let's again set all further row IDs to -1 for now and close the brackets for all those additional if statements to take a quick look at the intermediate results when we add that updated formula to all the subsequent cells in this column. It seems to perfectly work, starting with the separator row, which by the way is an intended result of the if error statement, because a row ID like /1 obviously cannot be interpreted as an actual row number. And then we have the expenses header, all the defined category items, and finally the total item, just as we have envisioned. To complete this formula, let's also include the savings section with its relevant row IDs. And again, we start with the separator row between the expenses and savings section, which is the logical next row if the previous row ID equals the expenses total row. Using the same notation as above, we're gonna return a unique text string with /2 for the second separator row. And then in the next cell we know if the previous row ID equals that /2, then this cell needs to have the savings header row as its row ID. Simple as that. Then as long as the previous row ID is smaller than the savings max row, we're gonna return the previous row ID +1. And as the final part of this formula, once the previous row ID equals the savings max row, we print the savings total row as the last relevant row ID. And all further cells in this column will be just -1. Let's close all these additional if statements, hit enter, and update all the subsequent cells in this column with this final formula. And once we got that huge formula bar out of the way, we can see how that setup perfectly plays out and displays exactly the relevant items in the items column. I assume you would love to see how this works when we add another category to one of these sections. So let's do that and add another income category. And as you see, it is automatically included in the item column as the row ID formula has now returned the row numbers for 4 instead of only 3 categories, and all the subsequent row IDs are just printed one cell lower than before. That is pretty amazing. Okay, so let's remove that category again and continue with our calculation columns in the budget dashboard sheet. One information we want to make available in each row is the row ID of the header of the section to which each respective item belongs. That means for all the income items, we want the row ID of the income header, which is 9 in this case, printed in this header row ID column. In a similar manner, we want to make available the row ID of the expenses header, which is 22 right now, for all the expense items, and of course the same for the savings section. Now, having the respective header row ID available in each row makes sense for 2 good reasons. First, we will know for each individual item to which type, so either income, expenses or savings, it belongs, simply by looking at the header row ID without leaving the row. And second, it is an important foundation for calculating the new sorted position of the category items, which will be covered in those currently hidden columns. In order to create this header row ID formula, we first need to generate some more information about the individual items based on the row ID by classifying them into either header, category, total, or empty item. In these 4 columns, we want to either have a 1 for true or a 0 for false for each individual row. And what's important here is those 4 columns are mutually exclusive. So for each row, we want to have exactly 1 true value in either of these 4 columns. Figuring out if a row ID belongs to a header or not is pretty easy, because for an item to be a header, its row ID has to either equal the income header row, the expenses header row, or the savings header row. So if any of these 3 conditions is fulfilled, the OR statement will return true, and to transform this into a number, we simply multiply it with 1. Pushing this formula to all the cells in the column shows us that we get a 1 exactly where the header items are. Perfect! Then figuring out if an item is a category or not based on the row ID alone would need a way longer formula. So let's skip that for now and take a look at the isTotal column first. Because for this one we can apply the same logic as for the isHeader column by creating a similar OR statement that checks if the row ID either equals the income total row, the expenses total row, or the savings total row. And if any of these conditions is true, the statement will return a 1, otherwise a 0. And this works just as fine, displaying a 1 for all the total items. The isEmpty formula is slightly different because for this one we're not gonna compare the row ID against any predefined names, but instead we simply check if the row ID equals either /1, /2, or -1, because that perfectly identifies all the possible empty rows. So we want to return a 1 in case either the row ID equals /1 or equals /2 or -1. Let's add this formula to the whole column. And as expected, we see a 1 for both the separator rows and all the rows that go beyond our relevant sections. Eventually, we can now determine the category rows simply by looking at the other 3 classifications. Because if an item is not a header, not a total, and not empty, it then has to be a category. So for the formula, all we need to do is apply the not function to negate an OR statement that checks if that item is either a header, a total, or empty. Only if all these are 0, which is the equivalent for false, the OR statement will also return false, and the overall statement will be true, and then return a 1. When we push this formula to the whole column, we get a 1 wherever a category item is. That's pretty amazing. And as a final check, we can quickly calculate a checksum over these 4 columns. And this proves that each row has exactly 1 true value in either of those 4 columns. With these new information generated, we can now set up the header row ID formula. And we start with an if statement that checks if the current item is a header. And if that is true, we're gonna return the row ID, as this is the row ID we are interested in here for this and all the other income items. In case it is not a header, it is either empty, a category, or a total item. And in case it is a category or total item, so not empty, then we just grab and return the value of the previous header row ID cell. And in case it is empty, then we just return a -1. And that's already it. Let's add that formula to all the cells in that column. And as you see, now we have the row ID of the respective type's header item available for every single item of that type. And we can directly make use of that information for adding the correct type name to each relevant item. And for this, let's just copy the formula from the item column and now instead of returning the item from the row number that is saved as row ID, we're gonna return the item from the row number saved as header row ID. When we add that formula to all the cells of that type column, each item now has the name of its corresponding type available in its respective row. With all these information available, we now want to dynamically calculate the tracked and budgeted amounts for all the income, expenses, and savings categories and totals. For the tracked amounts, we will dynamically extract and filter the data available in the budget tracking worksheet, while for the budgeted amounts, we will look up the values for the respective items in the budget planning worksheet. Of course, for both these calculations, the consideration of the selected year and period are crucial. Let's start with the tracked amounts, and for this we're gonna jump over to the budget tracking sheet to get a better understanding on how to approach the filtering and summing up of the relevant amounts for each item from this table. So for that, let's create some example calculations here right next to the table. Our target column of interest is of course the amount column, and we can reference all column values by entering equals and then selecting the whole column. As you see, when we reference a table column from the outside of the table, the notation is simply the table name with the column name in squared brackets. Only referencing this column will return an array containing all the values. And if we now want to filter those values, for example by a certain category, we could either use the sum product function, like we did for the balance calculation. However, I prefer to use the sum product function mainly for in-table calculations, or for applying more complex conditional arrays like we did here. But in our case now, we're only gonna use simple conditional arrays for filtering that only check which row of the column equal a certain value. Like for example, which rows of the table's type column equal income. This returns a same-sized array with a boolean true or false value for each row. And if we now multiply both these two arrays in a new formula, which means the tracking amount column times, in brackets, type column equals income, this returns a filtered version of the amount array with only the income amount values, and all the other values are set to 0. So calculating the sum over this array returns the total income. When we now change that filter to expenses, it will return the total expenses. Now what you see in this formula is the exact notation we need to apply in our track column. So building the sum over the amount column multiplied with one simple conditional array for every filter criterion. We remove these example calculations and start creating the base formula that contains the two filters which are the bare minimum required to be applied in any case, and these are filtering down to the respective type and the selected year. Any more specific filtering to a specific category or a specific month will then later be added as additional filters to this base formula. So let's create that base formula as the sum over the tracking amount column, and only consider those amounts for which the value in the tracking type column equals the type available in this row and the year of the value in the effective date column, so not the date column but the effective date column, equals the selected year. And then we close that statement, so when we add this to all the cells in this column, it will now return the total income, expenses and savings for the whole selected year in every row of that type. As the next step, let's make sure that we only return a value for the category and total items. And for the header and empty items, we actually want to have an empty cell instead. For that, we add if the item either is a header or empty, then return an empty string, and only otherwise return that formula that we have just built. Let's update the whole column, and now we only see calculation results for the category and total items. Based on these amounts, we can already see that the filtering to the respective type seems to work, but let's also quickly test the selected year filter by selecting the next year. As you see, for that year nothing is returned as no values have been tracked with an effective date in 2023, but when we adjust one of these records in the tracking table to have an effective date in 2023, then this formula returns nothing for the 2022 income, and it is now correctly visible when we select 2023. So that filter works as intended. Perfect. Now, I have called this formula in here the base formula, which is required in any case, because technically we have 4 different cases to cover, and thus 4 different formulas to build that will all contain that base formula. The 4 different cases result from having 2 options for the item classification, because either it is a total item, which then requires no additional filtering condition, or it is a specific category, which then requires an additional filtering condition. And then we have 2 options for the selected period, because either we have selected the total year, which again would not require any additional filtering condition, or we have selected a specific month, which then requires an additional filtering condition. So 2 times 2 options results in 4 different cases, and to accurately build up the decision structure to figure out which of these cases has to be applied in which row, let's temporarily save that base formula in another cell and remove it from in here, so that we can build up this structure from scratch as nested if statements with placeholder values for the actual calculations. Now, to build up this decision structure, first we're going to check if the item in that row is a total. And if that is true, we also need to know if the selected period equals total year. If both these are true, then we need to return the total for the respective type for the total year. If the selected period does not equal total year, then it is a specific month, and we need to calculate the total for the respective type in that specific month. Let's close that inner if statement and now consider the case that isTotal is not true. Then, as all the other classifications are basically ruled out, the item has to be a category item, and we're going to apply the same inner if statement to check what the selected period is. In case it equals total year, we now have to return the tracked amount for that category over the total year. And in the other case, the tracked amount for that category in a specific month. And that's it. Let's close that upper level if statement and push that formula to the whole column. Now we see for every item which calculation would be applied. Right now, with the total year selected, the category items all have the category and total year case returned, while the total items return the total and total year calculation. When we select a specific month instead, we jump to the corresponding month cases for both the category and total items, and that means that we have now ensured that always the correct case is applied for every item and period. Before we now insert the actual calculations for all those 4 cases, let us quickly improve the sample database in the tracking table by adding additional records for a month that is different from January, because with only 1 month in 2022 being represented in the data, we would not be able to tell the difference between the results returned for total year and a specific month. Let's decide for February to be the second month in our sample data, for which we're gonna add some income, then 2 records for expenses, and 1 record for savings. Great! Now with these additional data added for February, Let's jump over to the dashboard sheet and replace these placeholders for the 4 different cases with the actual calculations. For that, let's copy the base formula and for the first case where we calculate the total value for the total year, the base formula is all we need, since except from these 2 base filters for type and selected year, this case requires no additional filter for either a specific category or a specific month. For the second case, however, the selected period is not total year, but a specific month, so here we need to calculate the total for a specific month, for which we're going to add an additional filter to the base formula. We multiply the existing expression by a new conditional array that checks for every row in the tracking table if the month of the effective date equals the selected period. Remember that both the result of the month function and the selected period value are month numbers here. Before we also insert the calculations for the category items, let's quickly hit Enter, push this updated formula to all the column cells, and we see that now we have calculated values returned for the totals. Right now for the total year, and by selecting a specific month in this drop-down selection, this value can be now broken down into the totals for January and February. While all these subsequent months display a 0, as for these we have no underlying tracked data. For the category calculations, we also have these cases for either the total year or a specific month. For the total year, let's again paste this base formula. And while the selected year filter is already sufficient for covering the total year selection, so we don't need to add an additional filter for the month here, we instead need to insert an additional filter for the category. So let's add that filter right behind the type filter. And the notation is equally simple. We're gonna check for every row in the tracking table if the category value equals the item name available in the respective row in this sheet. And eventually, for this last case, which filters down to both a specific category and a specific month, we're gonna need both additional filters added to the base formula. So let's insert the category filter and the month filter to finalize this formula. Once we hit Enter and push the final formula to all the cells in this column, we get this beautiful result, where we now have the tracked amounts for the individual categories, which are then summed up in this total positions for the income, expenses, and savings section. And when we change that selected period from total year to a single specific month, then these amounts are broken down even more specifically. Amazing! Let's remove this temporarily stored base formula, reduce the size of the formula bar, and continue with the budget calculation. Retrieving the budgeted amounts for each item from the budget planning worksheet is much simpler, as here we have only one value for each item in each period that we just need to look up. And to look up the correct budget value, all we need to know is the row of the respective item, which we have already available as row ID, and also the correct column based on the selected year and selected period. As we have built these specific month headers as actual dates that contain the corresponding year and month number, and the total year is available as a single year number, we can use our selected year and selected period to build a dynamic lookup value and identify the correct column by using this row as a lookup row. Let me show you how that works. Just like for the track column, we're going to conduct this prior check if the item is a header or empty, and in that case we simply return an empty string. And if it passes that test, we're going to use the index function to return a value from a given array at a certain position. For the return array, we select all columns of that value input range, so starting at column E and ending at the last column, which is EM in our case. And since this is a two-dimensional, so a multi-row and multi-column array, we now need to provide both a row number and a column number to identify the position of a specific cell. You got to be aware that the row number and the column number you provide are always measured relatively against the starting row and starting column of the selected return array. Since our array covers the whole columns and thus starts at the very first row of that sheet, we can simply provide the row ID as the row number. For the column number though, our array starts at column E, which means to get the value for January 2022, we need to enter a 1, as this is the first column in the array that we have selected. Let's close that statement for now and update all the cells in the budget column with that new formula. As you see, returning the correct January budget for each individual item simply based on the row ID works perfectly. But of course we actually want to return the values for the period that is selected up there, which is total year right now. And the correct column number to show the total year budget for each item would be 13, as this is the 13th column of the provided return array. For now, let's just manually update that number and push it to all the cells in the column, and as expected, we now see the budget values for the total year. But of course, changing that column number manually each time is not what we want to do. Instead, we want to take a look at which year and period are currently selected, and then use that information to dynamically determine which column represents the selected year and period combination. For that, let us replace this hard-coded number with the match function, which expects a lookup value as the first argument. We know that in our budget planning worksheet, the total year columns have the year number only as their header value. So in case the selected period equals total year, we're gonna use the selected year as the lookup value. Otherwise, we know that the selected period is a specific month number, and we also know that in the planning budget sheet, those month headers have full dates with the respective year and month number as their underlying value. So in that case, we're gonna construct a lookup value as a date, using the selected year as year, the selected period as month, and for day we just provide a 1, so the first day of that month, to match the pattern that we have used in those period headers on the budget planning sheet. And with this lookup value being defined, we're gonna jump over to the budget planning sheet and select this period header row, starting at the same column as the return array we have selected earlier, and going all the way to the last column. So in our case from E9 to EM9. Let's make that an absolute range reference, and as we are looking for an exact match, let's enter a 0 for the last argument of the match function. And that is it. We only need to close that match statement and hit enter. And as soon as this updated formula is added to all the cells in the budget column, the budget calculation is now dynamically linked to whatever we have selected as year and period. These values are exactly the budget we have defined for January, as we can see on the budget planning sheet. Let's take a look at another example with these numbers budgeted for April, for example. And these are also perfectly retrieved. Here, of course, the track column is all zeros as we haven't tracked any money flows in our tracking table for that month. But yeah, both the tracked and budget column now perfectly work as they should. So the only thing left to do here is formatting them uniformly as accounting numbers with 0 decimal places. And at that point we have retrieved all the required data for this breakdown section in a condensed and fully dynamic way. Still, what's left to do in order to bring this breakdown section to the ultimate level is automatically sorting those category items within each type section by tracked amount as the first sorting criterion and budgeted amount as the second sorting criterion. That means for each section we only take a look at the category items and then find a way to reorder them based on the tracked amount and for equal tracked amounts, the budgeted amount. I know sorting a subset of items within each section while everything else around stays at its place seems like an impossible task at first. But once I've showed you how that can be achieved, you will be amazed at what is possible in Excel. Let's unhide those remaining columns, and as you can guess from the numbers of columns, implementing this in-section sorting mechanism is a multi-step process. The current order of category items within each section is determined by the order by which we have defined them in the budget planning sheet, and this order is then transmitted into this dashboard worksheet through the row ID. So what we need to do to reorder them is, in a first step, ranking the category items within their respective section, and then use those ranks to compute the row ID each category item should actually have in a sorted state. All the remaining pre-calculation columns here, except the last one, will be used for the in-section ranking. And then in the last column, we're gonna compute the sorted row ID, based on which we then print out the sorted category items in the visible breakdown section. As a fundamental step for the ranking, we need to know for each category item what is the range of items within this item will be ranked and sorted. And what is important to mention before we start, so far, for the whole process of getting these items and data into this dashboard worksheet, we were super focused on the row numbers from the budget planning sheet, which we have referenced as the row ID in this dashboard sheet. But now that we have those sorted data in here and try to rank them, we will have to take a look at the row numbers in this sheet to identify the relevant ranking ranges. So when we, for example, take a look at the income range, it is an important information for every income category item that it will be sorted within the range going from the row 14 to 16 of this sheet. For the expenses section, the relevant sorting range currently goes from row 20 to 28 of this sheet, and eventually for the savings section, the relevant sorting range currently goes from row 32 to 36 in this sheet. So to make this information available in every category item row, the first two columns will be sort min row and sort max row. Let's adjust the column size to make these headers fit in, add a gray border to visually separate it from what's coming next, and finally create dynamic name references for both columns so that we can instantly use these values in the subsequent calculations. So first for the sort min row, scope is still this worksheet only, and the row of that reference needs to be relative without a $sign. And then the same for sort max row. Perfect. To get the row number of the first income category item in this sheet, we can still make use of the row ID column, as it allows us to apply the match function for looking up the income min row, which equals 10 at the moment, in that column as an exact match. And that match function then returns the row number at which that lookup value has been found, which is 14 in that case. Pushing this first draft of the formula to all the cells in this column shows us that this calculation so far is totally independent from the row it is applied in. So we need to add a bit of conditional structure around it to make sure it is only used in the rows where it makes sense. That means we have to limit it to categories only in a first if statement. And since this specific match statement is meant to be for the income category items only, let's add a second level if statement that checks if the header row ID equals the income header row, which is true for all the items of the income section. And in any other case, we're gonna return an empty string for now. When we now update all the cells in this column with this improved formula, this information is only returned where it's supposed to be. And to also cover the category items of the expenses and savings section, Let's expand that formula by adding a similar if statement for the expenses section. So in case the header row ID is not equal the income header row, we then check if it equals the expenses header row. In that case, we would return this match statement looking for the expenses min row. And otherwise, if that condition is also not fulfilled, we eventually cover all category items belonging to the savings section and returning their minimum row number of the relevant sorting range. And in all other cases, we simply return an empty text string. Let's update the formula for all the cells in this column. And now each category item has that section-related information available. For the sort max row, we can then simply copy this formula and replace min by max in those match statements. And there we go, now we are able to determine the correct sorting range for any category item without looking at another row. Let's instantly make use of that row information for ranking the category items by their tracked and budgeted amounts within their respective sections. And we're gonna make that ranking a two-step process, as for ranking an item we need to provide the range within which we want to rank it. That range is obviously different for each section, and therefore we need to dynamically compose that range address first using the sort min and sort max row, and then dynamically pass it to the rank function in the second step. Thus, we're gonna have a tracked range and tracked rank column, and in the same manner a budget range and a budget rank column. Before we insert the required formulas, let's add another border separator after these 4 columns and also define dynamic name references for the tracked range the tracked rank, the budget range, and the budget rank column. Great! For composing the range address of the relevant tracked amounts, we can use the address function, for which we only have to provide the sort min and sort max values and the correct column. So let's start the formula by making sure that the values are only returned for category items, and then build that range address using the address function to first calculate the starting cell address based on the sort min row, and the column number of the tracked name reference, which correctly returns K14 for the income category items, K20 for the expenses category items, and K31 for the savings category items. And then we make this a range address by adding a colon as text, and then another address statement, this time providing the sort max row and the column number of the tracked name reference. Let's push that updated formula to all the cells in that column, and there we have all the relevant range addresses for ranking the tracked amounts in the next column. To now rank the amounts in their respective section from highest to lowest, we start by focusing on category items only, and then use the rank function, for which we're gonna provide the tracked value of the respective row as the value to be ranked, and the tracked range address transformed into an actual range reference using the indirect function as the range to rank the value in. For the last optional argument, we're gonna provide a 0 as we want to rank the values in a descending order. And eventually, in case the item is not a category item, we simply return an empty string. And that way, we now have dynamically ranked the track category amounts within each section. For the income section, those items are already listed from highest to lowest, while for the expenses section, for example, the first rank is found for housing at the top, while the item with the second highest amount is not at the correct position, just like the third and fourth highest amounts. What's important to know is that the rank function will return the same rank for equal amounts, as you see here for all those items with rank 5. Down there in the savings section, we only have 2 items with a value greater than 0, which are adequately ranked first and second. For the ranking by budget, we can use the exact same formulas and only need to replace the tracked reference by the budget reference. So for the budget range, let's copy this over and adjust the column to be the budget column now. That returns the correct ranges like L14 to L16 or L20 to L28. And for the budget rank column, we again start by focusing on the category items only, and then gonna rank the budget value of the respective row against all the values from the range defined as budget range. The order will be descending, and the default value for all the non-category items is an empty string again. Once this formula is available in all cells of that column, we see that also for the budget, the income category items are already listed from highest to lowest, while for the expense category items we get a whole nother picture, with the highest budget item being listed at the top, but the item with the second highest budget currently listed at the bottom. And while the first 3 ranks are all unique, you can see how the fourth rank is returned twice for those equivalent budgets. And here's another interesting thing to learn about this rank function. Because it returned rank 4 twice, it does not assign rank 5 to any item, but instead assigns rank 6 to the next item to always realign the ranks with the number of ranked items. We can make the same observation for rank 6, which is also assigned twice, and therefore there is no rank 7. Now we only need to combine those 2 rankings into one combined rank that considers the tracked rank first, and for 2 equal tracked ranks, then considers the budget rank. For that, we first gonna simply add them together, then with the next 2 columns normalize them, and in a last step make sure that every combined rank is unique. Again, we add a separating border to the right side of the section, and then define a dynamic name references for each individual column. Starting with the column comp rank, and remember to set the scope to this sheet only. Then the comp rank range, the comp rank norm, the comp rank norm run range, which is an extremely long name, I know, but I'm gonna explain that in a minute. And then eventually the comp rank unique. The combined rank is as simple as concatenating both these ranks together as a text string and transforming them into a number. Again, we focus on category items only, and then we use the number value function to transform the text string consisting of the tracked rank as the first part and the budget rank as the second part. And then return an empty string for all the non-category items. By simply adding the two ranks together with the tracked rank as the first part. When we now simply rank these combined numbers to normalize them, they will be first ranked by the leading digit representing the tracked rank, and for two items with the same tracked rank, like the 5 for example for these items with a 0 tracked value, it will then be ranked by their last digit, which represents the budget rank. So let's normalize them by first constructing the respective rank range for those comp rank values. In this formula again, we just need to replace the value within the column functions. And then for all category items, we apply the rank function to rank that composed comp ranked number within its relevant range. But this time, since we are basically normalizing descending rank numbers, we need to sort from lowest to highest, so in an ascending order. Let's add a default empty string for the other item classes, hit enter, and push that formula to all the cells in that column. And that looks pretty good. We now have normalized ranks that cover both the tracked and budget rank in one number. And the only thing left to optimize about this combined and normalized rank is we need to make those ranks fully unique to resolve a situation like you see here, where the tracked and budgeted value are fully equal, and for that reason we get the same combined normalized rank. That means for these items we basically need a third ranking criterion that uniquely differentiates them from each other. So what we decide to do is that we're gonna go through these ranks from top to bottom, and once a rank appears a second time, then we just increment it by 1. Because as we know, that subsequent rank number has been automatically skipped by the rank function. Then in case it appears a third time, we increment that rank number by 2, for the fourth time by 3, and so on. That means when looking at the rank in here and counting how often it already has appeared, we are now only interested in this row and the rows above. So we're gonna compose what I call a run range that starts only covering the first category items row and increases as we move down. So in this row, the run range will be only this one cell. In this row, the run range will be these two cells. And for this last item, we finally take a look at the whole range. Let's copy over this range composition formula and at first adjust the column references to now reference the comp rank norm column. And then when looking at the row number in this first address statement, we can leave it as is, as each individual range should start in the first category items row. For the second address statement though, we're gonna make that row number dynamic by returning the row number of the row that we are currently in. And that produces exactly these running range addresses as intended, which always reference a range covering the row itself and all the previous category rows of that section. And with that being set up, we can then create fully unique ranks for the category items by returning the normalized combined rank plus a COUNTIF statement that takes a look at this run range and counts how often the rank of the current item appears. And since the appearance of that rank in the row itself is counted as well, we need to subtract 1, which then means whenever a rank appears the first time, this second part of the formula will be 1 minus 1, which equals 0, so the original rank stays the same, while for the second appearance of the rank, the second part will be 2 minus 1, which equals 1. For the third appearance it will be 3 minus 1, which equals 2, and so on. Let's add the default empty string for non-category items, close that statement, and add it to the whole column. And as you see for these two appearances of the rank 8 for example, the first one only counts the number of appearances in this range, which equals 1, and then 1 minus 1 equals 0, and the rank stays as is. While for the second appearance, this range is considered containing the rank 8 2 times, and thus 2 minus 1 equals 1, and the rank is incremented by 1. And that way we now have fully unique ranks in each individual section. Amazing! This unique rank is the final result of that whole ranking process, so we can temporarily hide all those columns with intermediate ranking steps. As mentioned earlier, the final column of that pre-calculation section will now be used to compute the sorted row ID, which basically is the row ID that each item actually should have in a sorted state. And we will use this column as a lookup column so that we can then go through every row, take its row ID, look it up in the sorted row ID column, and then return the respective item which actually should be at that position from the row for which we have found the lookup match. Let's not forget to add a border to visually separate this column from the upcoming columns. And as this column will be used as lookup column only, this is the only column in this whole pre-calculation section for which we don't need to define a dynamic name reference. Calculating the sorted row ID is probably one of the easiest calculations in this whole pre-calculation section, because if the item is a category, all we need to do is adding up the header row ID and this calculated rank. Which will cover the exact same range of values as the original category row IDs in each section, but in a sorted order. And then for all the other non-category items, we simply pass through the row ID so that they stay at the exact same position. Adding this formula to all the cells in that column will give us these sorted row IDs, which we can now use to print out all those items in a sorted order in this first column of the visible breakdown section. So the formula here will be, if the row is empty, just return an empty string. Otherwise, we use an index match statement for which we're gonna provide this item column J as the return array. And to figure out the row of the item we want to return, we use the match function to look up the row ID of the current row in that sorted row ID lookup column with the letter X. And in whatever row we find a match, that's the row from which we want to return the item. Let's close that statement, autofill it to all the cells in that column, and now you can see the first result of that multi-step ranking and sorting effort. Because now every section is printed out, but with the category sorted according to the ranks we have calculated. Take the expenses section for example. Here, housing is the first rank category as it has the highest tracked amount. And the second rank goes to the groceries category, which is now accordingly visible at the second position. So this has been successfully repositioned. And again, the way we got that value into this row was we first took a look at the default row ID in that row, then looked it up in that sorted row ID column, to find the row of the item that should be at that position, and then return that item name from column J. That's the whole formula magic. And of course, we now want to return the according tracked and budget amounts next to the sorted items. So let's jump into the next column, and we start that formula in a similar way by first checking if that row is an empty row, in which case we're gonna return an empty string. But then, instead of directly returning the according tracked amounts, we first need to artificially add a header in case the row is a header row. Because if you look at the raw tracked and budget data over here, there is no header value available here, unlike for the item values. So let's first check if that row is a header row and return an appropriate header like tracked in that case. And only otherwise we're gonna return the actual data from the tracked column using the index match statement. This time with the tracked column K as the return array, and to identify the correct row, we again look up the row ID in the sorted row ID lookup column as an exact match. And then close that statement and autofill it to the whole column. There we have those tracked amounts with a header and perfectly sorted within each section. And a quick comparison of category name and tracked value with the original data confirms that this is perfectly legit. Amazing! Adding the sorted budget amounts in the subsequent column will now be a no-brainer, as we can just copy over and reuse the formula from the tracked output column. All we need to adjust is the header name and of course the return column in that index match statement to the budget column L. Once that formula is pushed to the whole column, we can perfectly see how for equal tracked values, the items will then get sorted by the budget values as the second criterion. And yeah, that is pretty fantastic. And now that we have brought all the available data into the visible breakdown section, we are at a point where we can just hide those pre-calculation columns and continue on the actually visible part of that worksheet. Based on these visible tracked and budget columns, we now want to calculate the most important KPI values in those remaining columns of the breakdown section, which is which percentage of the defined budget has already been tracked, what amount is remaining from the defined budget, and finally, in case the budget is already exceeded, by how much. Let's start by defining dynamic name references for both this tracked and budget column. And to differentiate them from the original data in the pre-calculation section, we're gonna assign the prefix out for output underscore tracked. Set the scope to this worksheet only again, and as always, make the row relative. And then the same for the budget column. We're gonna call it out underscore budget, set the scope to this worksheet, and make the row relative as well. For the percentage column, we start the formula with the same pattern that we have already used for the tracked and budget columns, with an if statement to check if the row is an empty row and returning an empty string in that case. And then if the row is a header row, we're gonna return a custom header name. Let's take percentage completed, but in a shortened form to make it fit into the column. And eventually calculate the percentage value in case the row is a category or total row, as out underscore tracked divided by out underscore budget. And since we cannot guarantee that the budget is not 0, we need to wrap this inside an if error function to catch potential division by 0 errors, in which case you want to return a simple dash. Let's close that statement, hit enter, and autofill the formula to the whole column. And of course we need to change the number format into percentage And there we go. Right now, we are comparing the tracked values for January and February with the budget for the total year. So obviously these percentage values are quite low. Let's select January as the period, and there we see not only how the sections automatically get resorted, but also that we have already reached 100% for some of those categories in that specific month. When we jump to February, the percentage completed for income and expenses is much lower, while we seem to already have exceeded our budgeted allocation to our stock portfolio by a good amount. Before we take care of the next column, let's also define a dynamic name reference for this column, as we're gonna need this for the conditional formatting rules that we're gonna add to this section after setting up all the columns. We call this out_percentage_completed. Again, we set the scope to this worksheet and remove the $sign to make the row reference relative. Perfect. The next column will calculate the remaining amount of the budget that has not been tracked so far. And again, we start by setting empty rows to an empty string in this first if statement, and then the header rows to a custom header called remaining in the second if statement. And for category and total items, we then do the actual calculation, in which we first gonna check if the budget is still greater than the tracked value, and only if that is the case we're gonna return the difference between the budget and tracked value. In case we have exceeded that budget, this column's value will be set to 0, because any excess of a budget value will be covered in the next column. Let's close these if statements, hit enter, and autofill the formula to all the cells in that column. And there we have all the remaining amounts as the delta between the budget and the tracked values. And for the column that calculates the excess of the budget values, we can simply refactor this formula in the remaining column by changing the header name to excess, then reverse this check to identify cases in which the tracked value exceeds the budget, and in those cases we're gonna return a reversed version of that statement. So the tracked minus the budget amount to get the excess as an absolute value. With the selected period currently being set to the total year, it makes total sense that we haven't exceeded any of those budget values at that point. When we select January, we see that we have a few positions for which we exactly hit the 100%, and thus both the remaining and excess amount are both 0. But for February we have one position down in the savings for which we have tracked a higher amount in our sample data than originally budgeted, and consequently we have this excess value displayed. As everything works perfectly from a calculation point of view, we can now focus on the visual design and formatting of that breakdown section. The first change we want to do is slightly reducing the font size for the whole section. Which leads to a more spaced and straightened out look. And in addition, let's set the vertical text alignment to the middle. Then for these 5 value columns, let's set the default horizontal text alignment to center, which is primarily relevant for the headers and the percentage column, because for all the absolute amounts in the tracked, the budget, the remaining and the excess column, we're gonna apply a standardized and clean accounting number format with 0 decimal places anyway. And as the last easy formatting step, we're gonna adjust the column sizes with a special focus on applying a uniform size for those 4 columns containing these absolute amounts. And once all that is applied, the section already looks so much cleaner. To bring this design to a whole nother level, let's dynamically format the header and total rows using conditional formatting rules. For that, let's select the whole section, then open the Conditional Formatting Rules Manager, And then create 3 individual rules for the income, the expenses, and the savings header. For identifying the income header, we're gonna apply the same technique as we have done previously for other calculations. So we're gonna apply this rule to the row for which the row ID equals the income header row. And the style we want to apply is this beautiful green fill. And for the text, we're gonna make it bold and give it a white style. Just like this. Let's apply that first rule, and that income header appears in an entirely new light. Let's create the rules for the other 2 headers simply by duplicating that first rule, then adjusting the formula to now look for the expenses header row, and of course change the fill color to this beautiful red tone. And there we go. Eventually, let's jump into the last rule, in which we're gonna look for the savings header row. And as the color of choice, we again go with this beautiful blue. Let's confirm and apply those changes, and there we have our dynamically formatted header rows for the income, expenses, and savings section. Let's set this checkmark at stop if true to avoid unnecessary calculations and improve the overall performance of that sheet. And now the only thing missing on this full section level is the formatting of the totals. And here we're only gonna define one single rule for all the 3 total rows. To identify those total rows, we can use the isTotalInformation. And for the formatting, we're gonna set a bold font style and an automatically colored upper border. Simple as that. Let's confirm these choices and apply the rule to complement the existing design. Simply beautiful. Let's move that rule down and also set the checkmark here before we confirm and close that window, as now we are done with the general section design. The last feature we want to add to this breakdown section are progress bars and the dynamic coloring in the percentage completed column. For that, let's select the percentage completed column only and open the Conditional Formatting Rules Manager. Here we still see the 4 rules that we have just defined for the whole section, but now with only the percentage completed column selected, we can add dedicated data bars for those percentage values. And for that, let's create a new rule. This time leave the rule type selected as this upper type called Format All Cells based on their values, and down below in the Format Style dropdown we can select Data Bar. And for a data bar we now have to define a minimum and maximum value. Let's go with number here to keep it simple and leave that value at 0. And for the maximum we also select the type as number and enter a 1, which is equal to 100% as the value. Eventually, we need to define the fill color of the bar, and here we go with this lighter gray, so that there is still enough contrast between the percentage number and the data bar. Let's click OK and apply this newly defined rule. Currently you see that this data bar rule is applied for both the categories and totals. We're gonna move it down in the rule hierarchy, and please be aware that with the rule above for these total rows having that stop if true option checked, this data bar rule will no longer be applied for the total rows. You know, I personally prefer it that way as it visually differentiates that total row from the category rows. However, in case you wish to have these data bars also being displayed for the totals, simply remove that check mark from the stop if true option up there. With that being said, let's close that window, and we now perfectly see those data bars, which are quite tiny right now as we have selected a total year as our period to view. But when we change that to one of the 2 months for which we have some tracked data, we see a different picture, with those data bars now being much larger, covering up to 100% of the cell. You might remember that for February we had that one stock portfolio position for which the tracked amount exceeds the budget, and that perfectly shows you that the data bar is limited to 100% even if that percentage value itself goes much higher. Now, to visually highlight the case of reaching or exceeding the 100%, we're gonna introduce one additional coloring rule for each individual section. So let's select this column and open the Conditional Formatting Rules Manager a last time for this breakdown section. And then start adding the first rule that will be applied when an income item has reached or exceeded the 100%. For this, multiple conditions have to be fulfilled. So we start with an AND statement that checks if the item is either a category or, at least if you wish to also cover those, a total. Then also make sure that the budget is greater than 0. Then of course the percentage completed needs to be greater equal 1. And finally, to limit this rule to the income section only, the header row ID of the item needs to equal the income header row. If all those 4 conditions are met, then we want to color the cell in that mid-light green. Now, when we apply that rule directly without having the Stop If True box checked, the data bar rule will still be applied and just prints the data bar on top. So to fix this, let's first move that rule down right above the data bar rule, and more importantly, check that box to stop the data bar rule from being applied in that case. And after that, only this beautiful green fill is visible for this 100% position. Amazing! For the expenses and savings section, we can again just duplicate this rule 2 times, move those duplicates down, and then adjust the second one to be only valid for items of the expenses section, and to color the respective cells in this mid-light red tone. Looks good to me. And eventually for the third rule, we're gonna adjust the formula to only be valid for items in the savings section, and set the fill color for that rule to this mid-light blue. Before we close that window, just as a quick reminder, in case you wish to have these coloring rules and the data bar rule apply to the total items as well, make sure that you uncheck the Stop If True option for the formatting rule above that is applied to all the total rows. I'm gonna leave it checked for now and exclude the total rows from these rules, as I think it's a bit cleaner, but you know, it's totally up to you. Let's click on OK to close that window. What a beautiful result! And even better, we can now watch the live impact of new records into this budget tracking sheet by displaying the tracking table and this budget breakdown side by side. For that, we only need to go to the View tab, then open a new window that automatically references the same live file, and in there we can then navigate to the budget tracking sheet. For such a new window, our current view and zoom settings are not retained. That's a bit unfortunate. So we need to first manually set the view settings to no grid lines and potentially adjust the zoom back to our default value. But then we can leave the full screen for this window, move that window to the right, enlarge it until only the breakdown section is visible on the left. And eventually, I recommend to also leave full screen mode for that primary window and make sure it's positioned on the left. In the budget tracking sheet, let's make sure that we can see all the columns of that table. So we would need to reduce the size of that details column. But before we do that, let's check if those grouped tile elements will not be affected by changes in the underlying column sizes. For that, we have to make sure that for all these grouped tile elements, these properties are set to don't move or size with cells. That way the tiles will stay at their exact position, totally independent from changes in the column sizes. And we can also scroll a tiny bit to the right. So now that looks pretty good, and we are ready to add some new records. To provide a solid data foundation for creating the dynamic charts in our summary section of the dashboard in the next steps, we're gonna enter some records for all the defined categories over multiple months. And as we have hard-coded the current date to be the 15th of March, it makes sense to enter sample tracking data up until this point. As we currently have a few records with an effective date in January and February, and we want to start entering data with a focus on January, let's filter the effective date column to just display the existing records for January before we start adding new records here. For entering those sample records, you can just follow me along, or if you prefer, add whatever sample records you would like to have. Just make sure that you pretty much cover every defined category and also have some variation in how you under or overperform certain category or total budgets between the different months. As we enter these new records into this table, we can now instantly see the impact on the percentage completion and the remaining amounts in the breakdown section, which is pretty cool and helpful. Especially when you think about how you can use that later for tracking your real budgets for the current month, and then can use that as a monitoring tool to always know how much is there left to spend in each expense category, and how much you are still supposed to earn and allocate to your savings. Once you're done with this first month, the breakdown section serves as your final performance evaluation against your originally set up budget. Now that we want to also add some additional tracking sample data for February, let's scroll over in the dashboard sheet to change the selected period to February. And in a similar way, in the budget tracking sheet, we're gonna change the effective date filter to now only display the corresponding February records only. Now, these existing records for February don't cover the first few days of the month, so why not add a few records right at the beginning of the month, as we can just easily bring them to their correct chronological position through sorting the date column at any time. And just like we did in January, we're gonna provide a paycheck position received at the end of the previous month that will be automatically effective and thus disposable in this month. One thing I also want to show you is the fact that even though we have implemented these data validations as drop-down lists, you can still type in the values directly. Obviously, only values from the drop-down list will be accepted, and this auto-completion is only available not before you have already entered the respective value before in that column. I think maybe for some of you, entering the data directly without leaving the keyboard might be the preferable way from time to time. So yeah, just do as you prefer. Now, after entering the records that are chronologically before the existing records, let's quickly sort this column from oldest to newest, and then we can just continue adding the remaining sample data for this month. The sample data that we have entered for February here is a good example of how only a small relative deviation from budgeted income and expenses has a tremendous impact on your savings potential, not only into the negative direction, like in this case, but of course also into the positive direction. Let's change the selected period in our dashboard to March now, for which we have not a single record in our tracking table yet. And for that reason, right now it is not possible to filter the effective date column to March records only, because we first need to provide at least one record for March before we can do that. So let's enter the paycheck from employment record here that's effective for March. And now we can filter down to that month to get this clean and focused view for our data entry. As already mentioned before, with our current date set to the 15th of March, we only want to enter sample tracking data up until this point. You can perfectly observe how the difference in days between the date of today and the date of the last record steadily shrinks as we enter new records. Later, when you track your actual money flows, it should be the goal to constantly keep that tracking lag in days as low as possible. With the last record having a date that is the same as our current date, that tracking lag is now down to 0 days, so technically these sample tracking data are now perfectly up to date, and we can just close that second window and maximize the primary window to full screen mode again. Before we start with the creation of the charts for the summary section in the dashboard, let's quickly jump over to the budget tracking sheet, which we have just edited in the other window. As you see, everything is just as we have left it before we closed that second window, and what I want to do now is removing that filter in the effective date column, then bringing all the records from all the months into chronological order by sorting the date column from oldest to newest. And since the overall table has grown a lot and we cannot see all the records at once anymore, it makes sense to select the first row here, go to the View tab, and click that Freeze Panes option for a smooth scrolling experience with a fixed header. Wonderful!